Talk about dark matter. I mean, you just mentioned it when we were talking about inflation. That's something that I know that we don't know a ton about, which is what makes it an interesting talking point. Maybe try and explain that a little bit to my listeners.
Yes, it's really one of the great mysteries. If you want to win the Nobel Prize, figure out what dark matter is. Uh, Dark matter, nobody had any idea that dark matter was out there. Just to, I don't know, give you some idea, it's believed right now that 22% of space consists of dark matter. So just imagine 22% of our universe consists of something we have no idea. Well, we do have a little bit of an idea, probably what it is, but nobody knows for sure. And then 74% of it is made up of dark energy. So we only know uh, about 4% of what our universe is made up of, which is the stuff that we're made out of, atoms and protons and neutrons, that kind of thing. So so this whole dark matter, the big question comes, well, how did they discover it? Well, they started, uh, just for yucks, they started looking at galaxies and how the mass rotated around galaxies, orbited around the center of galaxies. I, I think most people know this, that the center of most galaxies probably have a black hole in them. Our galaxy does. Milky Way has a black hole in its center. So black holes are have intense gravitational pull. And so when you put all this mass of stars that are going into that black hole and being sucked into that black hole, there's a tremendous gravitational pull at the center of the galaxy. Now think about it. If you look at the planets, and this is something that Kepler realized a long time ago, is that the closer you are to the sun, the faster you have to go to keep from being pulled into the sun by the gravitational pull. So we know now that, of course, as you move farther and farther away from the sun, the orbital velocity slows down. And we would expect that to be true in galaxies where there's this massive amount of gravitational pull towards the center of the galaxy. So you would expect that material, stars well, I didn't mean galaxies, but stars and the gases that go around the center of the galaxies would be traveling fastest towards the center of the galaxy. And as you moved outward where we are, things would be moving much more slowly. And it turns out that's not the case. And there are only two explanations for it. Either the general equations of general relativity and gravity are all wrong. Newton got it wrong. Einstein got it wrong. Or there's matter that is dispersed throughout our galaxy, which makes all the planets go about the same speed. But we not only have evidence from the speed at which the material that goes around the galaxies, the evidence of dark matter, but also there's this, well, I don't know if you're aware of this, but when Einstein discovered general relativity, Eddington, another scientist, realized that one way that we could test it was Einstein said that mass would, large gravitational masses would actually pull light towards them. So we can test that by looking at a star close to, say, the sun, and then when there's an ellipse and the sun's covered up, we can see where the starlight is, where that star is relative to the sun, because the starlight's going close to the sun, and then measure it where it is when the sun isn't affecting the light. And sure enough, it turns out that there is a gravitational pull and light is infected, and that's called gravitational lensing. And when we look out in space, we see things that are gravitationally lensed, but they're affected more by whatever's out there than we can see. So that's more evidence. You have more of a gravitational lens effect by objects in space than we would expect by the size of those objects. So we know there must be something more out there than just the visible matter that we see. So it's really incredible. Only 4% of our universe, we know what it is.
Do you think that when I think about exactly what you just said, and I think I go back to my, non-scientist brain and my visualization of the Big Bang, and you think there's a simple explanation for dark matter that we're going to stumble upon? Do you think it's going to be one of those things when we figure it out, where it's going to kind of plug into our model somehow, and we're going to be like, of course? Or do you think it's going to be something completely foreign that's going to rewrite science textbooks as we know it, and rewrite everything that everything that we know about physics and quantum mechanics and astronomy and everything thus far?
Well, if it's that way, we'll have to put a lot of physicists on suicide watch, because the standard model has been, when they discovered the Higgs boson, it really showed us that the standard model of physics is I hate to always use the word right.
Right, yeah,
but
it plugs right in.
Really
right?
Substantiated. But of course, there's always the possibility that dark matter could turn out to be so weird that the standard model, I guess, would be wrong. But I think there's an explanation out there that most physicists would subscribe to, and that's what they call weakly interacting massive particles. They call them WIMPs. And the idea is that you have some particles out there that are impossible to detect on Earth, not impossible, but are hard to detect. And as a consequence, because they have no charge, they don't behave the way regular matter does, that they've been hiding from us all along. So there are now huge studies and research projects going on to try to discover what dark matter is. And I haven't read anything probably in the last couple of years on the research on dark matter. But I know that they have some of the old gold mines. I think even one in the United States in North Dakota, they've put these big baths of liquid that would be sensitive to detection of anything passing through the Earth. They have to cut out all the other things like radiation so that they can only measure these weakly interacting massive particles that come through. Others have postulated some cold dark matter that we can't see, but they're out there trying to detect it. It's I wouldn't be surprised if any day now we had somebody announcing the discovery of dark matter.